Okay, here we go. So for the practice quiz, here it is. The first problem, we're finding all the asymptotes, and then we are stating the domain of each of these functions. So the first thing I would do with each of these is go plot it in Desmos or something like that first, so that you know what you're looking for, so you don't waste any time looking for things that aren't there. So I've already typed all of the ones from the quiz into Desmos. I'm just going to highlight this first one. We had that x squared minus 2 over x squared minus 4. So here we can see we're looking for 2 vertical asymptotes and a horizontal asymptote. So from the equation itself, so this is 1a, it was x squared minus 2 over x squared minus 4. Here we go. Okay, so from the equation itself, we can tell that our vertical asymptotes are going to be when you set the denominator equal to 0, so x squared minus 4 equals 0. X squared minus 4, you can either kind of guess and check your way into it, or you can factor this thing, x minus 2 times x plus 2, since it's difference of squares. So then x equals 2 and x equals negative 2 will be our vertical asymptotes. And then for the horizontal asymptote, that has to do with the degree of the top and the degree of the bottom. N is the degree of the top, which is 2. M is the degree of the bottom, which is also 2. So that tells me that my vertical or my horizontal asymptote is going to be a ratio, y equals a ratio of the coefficients here. So since the coefficients are both 1, it's just going to be y equals 1 for our horizontal asymptote. All right, and then there are no oblique asymptotes for this one. So we found our vertical, we found our horizontal, then we just need to find the domain. And the domain is only restricted here by those values of the vertical asymptote. We can see that there's a break. So we'd have to go negative infinity to negative 2, union with negative 2 to positive 2, union with 2 to infinity. So that's how we exclude the values of negative 2 and positive 2. So there's a complete answer for 1A. Any questions about 1A? Okay, if you do have any questions at any point, feel free to unmute yourself and say so, or type in the chat. Moving along to 1B. 1B says g of x is x to the third minus 8 over x plus 4. So again, what I would probably do first is go over and graph this thing. So highlighting that graph, this is what we get. This one is an important one to zoom out on, because we notice that the function continues clear up here. So there is an asymptote, a vertical asymptote, because it does have a denominator with x minus 4. So we're looking for a vertical asymptote, but we're not looking for any horizontal or oblique asymptotes here. And we'll get to why in a moment. So again, the vertical asymptote, we just set the denominator equal to 0. Or, oh wait, was it minus 4 or plus 4? Plus 4, whoops. So in Desmos, I graphed it slightly incorrectly here. There we go. Okay, but similar idea. We have to zoom out to see it. It's just moved around. Okay. So x plus 4 equals 0 tells me that x equals negative 4 is my vertical asymptote. Okay. Then if we were looking, well, we noticed by the graph there's not any horizontal asymptotes. We would note horizontal asymptotes if we had the degree of the bottom greater than the degree of the top or equal to the degree of the top. But the top here, n is 3 and m is 1 on the bottom, since the degree of the bottom is 1. So that means we're not looking for any horizontal asymptotes. We're not going to find them. And then also we're not looking for any oblique asymptotes, because for that to be the case, the degree of the bottom would have to be 2, or the degree of the top would have to be 2, because there can only be a difference of 1 between them to have an oblique asymptote. So there's no horizontal, there's no oblique for this one. So then our domain is what we would jump to next, which would be -infinity to -4, and then -4 to +infinity. So we're just excluding that value of -4. Okay, so there's 1b. Next, we'll move on to 1c. All right, 1c said h of x is 8 over x plus 4 times x minus 2. It's all nice and factored for you already. So again, I would jump over to Desmos and take a look at what the graph tells me. For this one, we might want to zoom in a little bit first to get a better idea of what's going on here. We are looking for 2 vertical asymptotes and a horizontal asymptote, which hopefully makes sense because on the bottom we have 2 different things that we could set equal to 0. So that would be kind of an indicator of what's going on with our vertical asymptotes. So here we go. 8 over x plus 4 times x minus 2. So for the vertical asymptotes, again, we're setting the denominators equal to 0 here. X plus 4 equals 0, x minus 2 equals 0. To get x equals -4 and x equals +2 for our vertical asymptote. Okay, and then for horizontal, if we look at our notes from our asymptotes 2.5, you might notice that when the degree of the bottom here, m, is 2, and the degree of the top, n, is 0, because there are no x's up there. So since the degree of the bottom is greater than that of the top, our horizontal asymptote is just going to be y equals 0, or otherwise known as the x-axis. So either of those is a fine representation of our horizontal asymptote. And then there are no oblique asymptotes here. Remember, if we were going to find an oblique asymptote, like on this one, if this was x squared plus 4 or something like that, you would divide these, and then the remainder, or not the remainder, the quotient minus the remainder is going to be your oblique asymptote. But we didn't have one of those on any of these. Okay. Any questions on number 1? Oh, wait, we didn't finish this, the domain. Then we just have to exclude 2 and -4. Okay. Any questions on number 1, part A, B, or C? Okay. So then moving right along to number 2, we have to solve the equation, show your work finding common denominator, and all those things. So let's write this down real quick. Number 2, x over x plus 1 minus x minus 1 over x equals 1/20. Okay, so for this one, we need to find a common denominator. And looking at these 3 denominators here, they don't really have a whole lot in common amongst them. So our common denominator is just going to be all of them multiplied. Okay, all of them multiplied. Okay, so then, since this needs to be our common denominator, we have to figure out a way to make each of these into this denominator here by multiplying on the top and the bottom by what they don't have. So for example, this one, the denominator doesn't have the x or the 20. So then we need to have multiply on the top by the 20 and by the x for that one. So if you want to make a note of it, what you multiplied, you can. At this point, since we're multiplying by things to make a common denominator, you can get rid of the denominator. Okay, so this denominator has x. It doesn't have the x plus 1 or the 20. So we need to multiply by 20 and by x plus 1. And then this one only has the 20, so this one needs to be multiplied by x and x plus 1. Okay, so now we've got our common denominator. We've gotten rid of the denominator because it's now common. Now we need to just simplify all of this, multiply everything out, and go from there. So x times 20 times x is 20x squared. X minus 1 times x plus 1 gives us x squared minus 1, and then times 20. And then also we have this negative out in front here. So we have minus 20x squared plus 20. And then this multiplied out gives us x squared plus x. All right, so then 20x squared minus 20x squared cancels each other out. We get 20 equals x squared plus x. So 0 equals x squared plus x minus 20. And then at this point, you can either factor if you can think of something that would help us factor this nicely, or you can toss it into Desmos and see where the zeros are. Either way is fine. I'll factor this. Things that multiply to negative 20 and add to 1 would be 5 and negative 4. So we get x minus, or plus 5, x minus 4. So x is negative 5 or 4. Then we want to go back and check and make sure that neither of these creates a dividing by 0 issue up here, since this did come from a rational equation. And if I plug in negative 5, we're good to go. If I plug in 4, we're good to go. So either of these will work as our answer. Okay. Any questions from number 2? Any numbers we're not sure where they came from? Anything we're not sure why or how it happened? Okay. Then moving along to 3A. 3A tells us that we should solve the inequality and express our solution as a graph and in interval notation. X squared plus 12 is less than or equal to 3 minus 6x is our first one. So the first thing that I would, well, since it's just a quadratic one, the first thing I would do is write it down and start moving things around to solve it. But you could also graph it first if you would like, and I will show what that looks like in a moment. So here's number 3A. We have this going on. I'm going to move everything to one side. So we have x squared, and then we'd have plus 6x if I added 6x to both sides. And then minus 3 on both sides would give me plus 9, less than or equal to 0. Then you could factor this thing and you'd get x plus 3 times x plus 3. And so our only 0 here is x equals negative 3. But it has a multiplicity of 2. So what that's telling me is that this thing rests on the x-axis at negative 3. So this is probably where you should either go look at the graph or start plugging in values. If you're making a table of values here, or a sign chart, in your sign chart, x equals 0 would be over here. X equals, I don't know, we can go -5 would be over here. F of 0 is 9. And then f of -5 would be, let's see, 25, 30 would give us 55, 64. So notice that they're both positive. So without even graphing this on my own, or on a grapher, you can tell that at -3 here, this thing is doing that. Because we know that it's 0 at -3 and that it's positive on either side of -3. Okay. So if I know this, then I'm looking for places where this function is less than or equal to 0. Is this function ever less than 0? No. Is it ever equal to 0 though? Yes, at -3 right here. So -3 would be the only spot that I have that or the only place where x satisfies this. So you could write it like that. You can write it like that if you like, and then expressing in terms of a graph here, or on a number line, you would just have one filled in dot at -3, and that would be the representation of your solution. Okay, so that's the only value of x that satisfies this statement. And looking at it on Desmos, we can confirm it. If I plug in x squared plus 6x plus 9, this is what we get. It's resting on the axis at -3, just as we expected this thing to. And then if I plug in less than or equal to, the whole thing, it just shows you one line right here at -3. One solid line there. Okay. So that's 3A. Next thing we want is 3B. 3B is a cubic. We have x cubed minus 9x squared plus 11x plus 21 is greater than 0. This one I would probably toss into the calculator right away, since this cubic doesn't look like it's going to do much in the way of factoring nicely for me. So if I toss just the cubic in, we notice that our zeros are at -1, 3, and 7. -1, 3, and 7. Okay, so on my paper, I might write down that our zeros at -1, 3, and 7. And if I was making a sign chart, that's what I would put on my sign chart. Okay, so from here, you could plug in numbers that, like, -2 and 0 and 4 and 10 or something like that, and figure out if it's going to be positive or negative. But since we do have graphing technology, we can notice here that up until -1, this function is negative. So on my sign chart, I would put that it's negative until we get to -1. Then we notice that it becomes positive between -1 and 3. So then I would put down that it's positive in this interval. And then it becomes negative again between 3 and 7. And then it becomes positive again after 7. And we are looking for the places where it is greater than 0, because that's what we were given up here. That means we're looking for places where it's positive, but not equal to 0. So that would be the interval from -1 to 3, and the interval from 7 to infinity. So if I was expressing it in set notation, that would be my answer. If I was expressing it using a number line, we'd have -1, 3, and 7 on my number line. I would be taking open dots and then the interval between from 1 to 3, or -1 to 3, and then an open dot on 7 with the arrow pointing to the right. Okay, so that would be my whole answer to 3B. Any questions at this point on any of the practice test at all? Okay. Well, if there are no questions, then you guys, I have the exit ticket is posted, and you guys are free to do that and head on out of here, and I will see you tomorrow. If you have questions, feel free to stick around and ask them.